In this video, we're going to talk about how to calculate the pH of a solution, be it an acid or a base, without the use of a calculator. So let's start with this example. What is the pH of a 4 times 10 to the minus 3 molar hydrochloric acid solution? The formula that we need to use to calculate the pH of a solution is this one. The pH is equal to negative log of the H plus concentration. That is the hydrogen ion concentration, which is the same as the hydronium ion concentration. It turns out that the H plus concentration will be the same as the HCl concentration. HCl is a strong acid, and so it dissociates completely into hydrogen ions. So in order to calculate the pH of the solution, we need to find the value of negative log of 4 times 10 to the minus 3. Now, to get a range of the answer, here's what you can do. Focus on this number, negative 3. Do you think the pH will be between 2 and 3? Or will it be between 3 and 4? What would you say? Take a minute and think about it real quick. The answer is always going to be the lower range of the two. So it's going to be 2 to 3. Knowing that, we can eliminate answer choice A and answer choice E, and D as well. So our answer is either 2.4 or 2.5. Now, what else can we do? It turns out that negative log of this number is going to equal the positive value of that exponent, 3, minus the log of whatever number you see there, in this case log 4. Now, in order to estimate the pH without a calculator, it's very useful to know the values of the logs all the way up to 9. So if you know log 2 to log 9, this will be very helpful. Log 4, according to this table, is 0.6. So the answer is going to be 3 minus 0.6, which is 2.4. And so B is the correct answer. Now we can confirm this with a calculator. If you type in negative log of 4 times 10 to the minus 3, the exact answer is 2.39794, which rounds to 2.4. So this is a good estimation of the answer. Now let's move on to the next problem, number 2. What is the pH of a 8 times 10 to the minus 4 molar hydroiodic acid solution? So go ahead and take a minute and work on this example using the method that we covered in the last problem. So let's begin with the formula. The pH is equal to negative log of the H plus, or you could say the H3O plus concentration. HI is a strong acid like HCl, and so it's going to completely ionize, which means that the concentration of HI is the same as the concentration of H3O plus. For weak acids, you need to deal with Ka, the acid dissociation constant, but we're not going to cover that in this video. I could post a link in the description section below if you need help with those types of problems. Now let's replace H3O plus with the concentration of HI. So that's 8 times 10 to the minus 4. So let's focus on this number, 4. Let's ignore the negative sign. So we know the answer is either between 3 to 4 or 4 to 5. Which one is the correct range? Well, based on the last example, we're going to pick the lower of the two ranges. So the answer is going to be between 3 and 4. So we can eliminate answer choice A and E. So it's either 3.1, 3.5, or 3.9. Now, here's a shortcut method that we used in the last example that will get us the answer. It's going to be the positive value of this number, 4, minus the log of whatever number you see here. In that case, that's 8. So it's 4 minus log 8. Using the table, log 8 is 0.9. So it's 4 minus 0.9, which means it's 3.1. So that right there is the pH of the solution. So answer choice B is the correct answer. But as always, it's good to confirm with a calculator. Negative log of 8 times 10 to the minus 4 is equal to the exact answer, 3.0969, which rounds to 3.1. So that's a good approximation of the answer. Now, for those of you who want an explanation in terms of why negative log 8 times 10 to the minus 4 works out to be 4 minus log 8, I'm going to explain the mathematical process behind that later in this video, for those of you who might be interested. But for those of you who want to estimate the pH quickly using this method, we're going to work on a few more examples before we explain why this works. Now let's work on this one, number 3. Estimate the pOH of a 3.5 times 10 to the minus 5 molar sodium hydroxide solution. So let's begin with the formula. The pOH is equal to negative log of the hydroxide ion concentration. And sodium hydroxide is a strong base. It's a strong electrolyte. It ionizes completely in water. And so the concentration of sodium hydroxide is the same as the concentration of hydroxide. If you put NaOH in water, it will completely dissociate into these two ions, 100%. So that's why the concentration of these two species are the same. So let's replace the hydroxide ion concentration with the value that it equals. That's 3.5 times 10 to the minus 5. So focusing on this number, we know that the pOH has to be between 4 to 5 and not 5 to 6. And all of the answers are between 4 to 5, so that doesn't really help us in this example. Now we know that the pOH is going to be the positive value of this number, 5 minus log of 3.5. Now this is where it gets tricky, because we know the value of log 3. Log 3 is 0.48. Log 4 is 0.60. So what's log 3.5? Well, 3.5 is right between 3 and 4. So for this example, we can average log 3 and log 4. And that will be a good estimate of log 3.5. Not the exact answer, but an estimate. Hopefully, that's enough to distinguish the right answer from the wrong one. Log 3 is 0.48. Log 4 is 0.60. And 60 plus 48, that's 108. 108 divided by 2 is 54. So the average of 0.48 and 0.60 is 0.54. So this becomes 5 minus 0.54. So now we got to do some subtraction. For those of you who are wondering how you could do this mentally, break down 0.54 as 0.50 and 0.04. 5 minus 0.5, that's 4.5. And think of 4.5 as 4.50. 50 minus 4 is 46. So this is 4.46. That's going to be the pOH of the solution. And if you type in negative log 3.5 times 10 to the minus 5, you're going to get 4.45593. So that rounds to 4.46. Thus, C is the correct answer for this example. Number 4. Estimate the pH of a 7.4 times 10 to the minus 4 molar potassium hydroxide solution. Now, be careful with this problem. So we know the hydroxide concentration. It's 7.4 times 10 to the minus 4. Now, using that, we can calculate the pOH of the solution. It's negative log of the hydroxide concentration. So it's negative log of 7.4 times 10 to the minus 4. But now, this problem is asking for the pH of the solution. How can we find the answer? Well, we know that negative log of this number is going to give us an answer between 3 and 4. But none of the answers are in that range. And that's because the pH is equal to 14 minus the POH. So 14 minus 3 is 11, 14 minus 4 is 10. So thus the pH is going to be somewhere between 10 and 11, which all of our answers are in that range. So which one is the correct answer? Well, first, let's begin by evaluating negative log of 7.4 times 10 to the minus 4. So it's going to be the positive value of that number, 4, minus log of the number that we see here, 7.4. So what is log 7.4? Log 7 is 0.85, log 8 is 0.90. And it's not like we're trying to find log 7.5 where we could simply average the two. So we need to do something else here. We know our answer is between 0.85 and 0.90, but it's going to be closer to 7. So what we're going to do is we're going to take the difference of that range and we're going to multiply it by 40% because of the 0.4 and then add it to the lower part of the range, 0.85. So 0.90 minus 0.85. So that's the difference, or that's the range of the two values. And then we're going to take the 0.4 and multiply it by that range, basically taking 40% of that range, and we're going to add it to the lower part of the range, 0.85. So 0.90 minus 0.85, that's 0.05. And we can't use a calculator for this. Now, we know that 4 times 5 is 20. So what's 0.05 times 4? 0.05 times 4 would be 0.20. So 0.05 times 0.4 would be 0.020 or 0.02. You can also multiply it by hand if you prefer that way. So we have 0.02 plus 0.85, which would be 0.87. So log 7.4 is 0.87, which is between 0.85 and 0.90, but it's closer to log 7. It's close to 0.85. So this is going to be 4 minus 0.87. Now what is 4 minus 0.87? So what you could do is break it down into 0.80 and 0.07. So 4 minus 0.8, that's going to be 3.2 or 3.20. And 20 minus 7 is 13, so 3.20 minus 0.07, that's going to be 313. So now we have the POH. We can now use this formula to calculate the pH. So the pH is going to be 14 minus 3.13. So we can break it down into 14 minus 3 minus 0.10 minus 0.03. So 14 minus 3 is 11. 11 minus 0.1, that is 10.9. And 10.9 or 10.90 minus 0.03, 90 minus 3 is 87, so this is going to be 10.87. So that's how we can estimate the pH of this solution without a calculator. So answer choice A is the right answer. But to get the exact answer, if you type in 14 minus log 7.4 times 10 to the minus 4, I take that back. That should be, there's two negative signs here. There's this negative and this one. So it's 14 plus log 7.4 times 10 to the minus 4. That's going to be 10.869, which rounds to 10.87. So A is the correct answer. Let's work on one more example. Number 5. Estimate the pH of a 3.3 times 10 to the minus 2 molar hydrobromic acid solution. So for this problem, it's not as complicated as number 4. All we need to do is take the negative log of the H plus concentration, which is going to be 3.3 times 10 to the minus 2. So we just got to focus on the math. Looking at this number, we know the pH is going to be between not 2 and 3, but 1 and 2. And all of the answers are in that range. Now the pH is going to be the positive value of that number, 2, minus log of what we see here, 3.3. So now we need to use our table. What is log 3.3? Well, we know it's going to be between log 3 and 4. That is, it's between 0.48 and 0.60. So we're going to take the difference of that range, 0.60 minus 0.48, and we're going to multiply it by 30%, or 0.3, based on what we see here. And then we're going to add it to the lower number of that range, which is 0.48. So 0.60 minus 0.48. 60 minus 48 is what? We know that's 12. So 0.60 minus 0.48 has to be 0.12. Now what is 0.12 times 0.30? We know that 12 times 3 is 36. 0.12 times 3 has to be 0.36. So let's think about this. If 0.12 times 3 is 0.36, what is 0.12 times 0.3? 0.3 is 10 times less than 3. So 0.12 times 0.3 is going to be 10 times less than 0.36, which means it's going to be 0.036. So what we have right now is 0.036 plus 0.48. So we could add these two numbers. 3 and 8 will give us 11. 4 and 1 will give us 5. So this is 0.516. 0.516 is between 0.48 and 0.60. So we can work with that. So that's going to be log 3.3. It's 0.516. So this is going to be 2 minus 0.516. So what is 2 minus 0.516? So let's break it down into 2 minus 0.5, and then the remaining 1/6 part, that's going to be 0.01 minus 0.006. The 6 is in the thousandth place, the 1 is in the hundredths place. So 2 minus 0.5, we know that's 1.5, or 1.50. Now 1.50 minus 0.01, 50 minus 1 is 49. So this is going to give us 1.49. And then minus 0.006, so let's add a 0 here. 490 minus 6 is 484. So 490 minus 6 is, or 1.49 minus 0.006, that's going to be 1.484. So that is our answer, which we can go with answer choice D. And if you plug in negative log 3.3 times 10 to the minus 2, you get 1.481486. So it's still about 1.48. So that's what you can do to estimate the pH of a solution without the use of a calculator. Now, I'm going to use this example to show you why we can basically take this expression and convert it to what we see here. So here's one property of logs that you need to be familiar with. Log a to the x is equal to x log a. You're allowed to take the exponent and move it to the front. Now here's another property that we're going to use. Log a times b is equal to log a plus log b. So that's how we could take a single log and expand it to 2 logs. So let's start with the expression negative log 3.3 times 10 to the minus 2. So this is going to be a, this is going to be b. We're going to use this formula to split it into 2 logs first. So we're going to get negative log 3.3 and then another negative log of 10 to the minus 2. We have to distribute the negative sign. Now what we can do is take the negative 2, move it to the front, as was mentioned before. So this is going to be negative log 3.3 and then minus negative 2 log 10. Now log 10 is 1 because if you don't see a base, it's always assumed to be 10. So right now what we have is negative log 3.3. The two negative signs will cancel, so we're going to have plus 2 times 1. And I'm going to reverse it. So I'm going to write the 2 first and then minus log 3.3. Because let's say if you have negative 4 plus 5, that's the same as writing it as 5 minus 4. They both equal 1. And thus you can see that these two expressions are the same. So that's why I can rewrite this expression as 2 minus log 3.3. So now you see the mathematical reason of why it works. So that's basically it for this video. So now you know how to estimate the pH of a solution without the use of a calculator. Thanks again for watching.